8.4, matrix algebra. You know how when you're doing algebra you solve equations? It's kind of the idea, only we're doing matrix equations. Don't worry, we'll lead up to it. Okay. First thing we're learning about is adding and subtracting matrices. To add or subtract matrices, they must be the same dimensions. So, for example, if matrix A equals 3, 6, 2, negative 1, 0, 8, and matrix B equals 2, 3, 9, negative 2, and I want to find A minus B, what's the answer? Good job. So if you don't need to write all that down because it's pretty obvious that they're all different. Like this is 2 by 3 and this one's a 2 by 2, so they're different dimensions, so it's not possible, right? Okay. Let's do something else instead. Let's do a matrix C. What if I wanted you to find, I'm just going to try and combine two things in one step. Let's do 2A minus C. What would that mean? Any ideas? So what does it mean to multiply A by 2? Any ideas? No. Okay, so let's talk about that first. This here is called scalar multiplication. And that's where you take that number and you multiply every element in the matrix by that number. So multiply every element in matrix by a number, which is called a scalar. For some reason, when it's a single number like that, we call it a scalar. When we're working with matrices, and we have matrices and we have scalars. So we have matrix multiplication and we have scalar multiplication. Anyway. Okay, so now let's do this problem at hand here. So what does this mean we're going to do? So multiply everything in matrix A by 2. So 2 times everything in matrix A minus each thing in matrix B. And when you subtract stuff like that, you have to subtract corresponding numbers. So like you'd subtract 2 times, you'd go 2 times 3 first, and then subtract that 2, right? Okay, so let's put this up. So is that okay? Okay, so I'm just going to kind of do that process in my head. Is that all right? Here, I'll just write down the note I just said. Subtract corresponding elements. And elements, of course, are the numbers in your matrix. Okay, so we got 2 times 3 is 6, minus 2 is 4. 2 times 6 is 12, minus 0 is 12. 2 times 2 is 4, minus a negative 1. 5. Good. Okay. 2 times negative 1 is a negative 2, minus a negative 7. 5. Negative 2 plus 7 is also 5. Good. 2 times 0 is 0, minus 12. 2 times 8 is 16, minus 9. So that should be our answer. Would it be really easy to make teeny tiny mistakes in those? Yeah, be careful. Okay. Another thing you need to know about this multiplication, addition, this addition subtraction stuff, is that sometimes they have you work with the identity matrices. So just so you know, an identity matrix is the one we used in section 8.2. We call identity matrix with the letter I, capital letter I. So I sub 2 would be a 2 by 2 that looks like this. Does that look familiar? I sub 3 would be an identity matrix that looks like this. So it has a diagonal of 1s. And the reason it's called an identity is that in a bit when we learn how to multiply matrices, if you multiply by an identity matrix, nothing changes. It's kind of like the number 1 is just is a multiplicative identity. If you multiply by 1, nothing changes. So that's also the case here. If you multiply by an identity matrix, it doesn't change anything. But we haven't learned multiplication yet, so that doesn't apply until we learn that. However, what if you wanted to do like 3 times I sub 3? What would that mean? That would be a scalar multiplication where everything is multiplied by 3, and of course the zeros would remain 0, so instead of a diagonal of 1s, it would have a diagonal of 3s, right? Get the idea? So all that stuff is pretty easy. Do I need to spend more time on it? Okay, that's good. Okay, next thing we need to do, I'm going to stop the video so we can keep them short.